So we have another piece of home build kit here. In a previous video, we uncovered a resistor substitution box that came from an estate sale. This is another piece that came from that same estate sale, and I'll recap that here. Boeing engineer who had passed. The contents of his house was being auctioned off. He had a lot of test gear down in the basement, but it was like television aligners. It was tube stuff. Almost all of it was based around tube electronics. It was there Friday, Saturday. When I went back Sunday, none of it had sold. So I made an offer for all of it. It was accepted. I got it cheap. I mean, that afternoon they were going to start just throwing stuff into the dumpster. So they were selling stuff super cheap. So took it all. Majority of it went to the Mike and Key Hamfest out in Puyallup, Washington several years ago, where I tried to sell all the items for $5 a piece. And when it hit noon down there on Saturday, I made everything free, and it all found homes. So I was glad to see it not end up in the dumpster and I'll find homes. But this is one of the pieces I held on to. AC line, external AC input. There's an AC input connector here. We can also, like I say, use an external. There's a circuit breaker. There's a high-low and a ground out. Something Hertz variable power supply. There is what feels like a wire-wound potentiometer here that runs from 0 to 100. Maybe it's a rheostat, a small rheostat. I'm not sure. We won't know till we open it. It seems like the weight is concentrated in the center here. You know, this may well just be a rheostat in a box. If it is, that's still pretty cool. So before we plug it in, let's take it apart and take a peek inside. Especially because it gets plugged into the wall. I really don't want damaged electronics or aged electronics to fail. Variable, maybe that said 60 Hertz variable power supply. That may have been a 60 right there. It's hard to say. I had taken this as a variable frequency power supply, but I'm guessing that's not what it is. I don't think there's enough electronics inside for that to be the case. This is my first time opening it as well, so you're here with me for the little adventure. I was recently down at my storage unit and spotted this in that resistor substitution box we looked at in the previous video, and went, you know, I kept those for teardowns and to see if they are maybe useful in my lab. So let's go ahead and do that, which is what we're doing now. So very homemade. This bottom aluminum plate here, very homemade. It's a large rheostat. Or variable transformer. Let me take that back. It is a variable transformer. Type 108 power stat variable transformer. Input 120 volts, 50-60 hertz. 120 volts, 60 hertz. I guess there's multiple taps on it. Output 0 to 120 volts on 1 to 3. Amps 2.25, so 2¼ amps. So actually pretty sweet. Circuit breaker here so you don't damage it. Nice, very large toggle switch. It's a nice looking rheostat. I've got a very large Variac, very high power Variac here that I occasionally use when I want to like reform capacitors and old stuff, or don't trust, 50-year-old power supplies. So, linear power supply, so I'll bring them up slowly. That's a very nice variable transformer. So let's give this a play. I guess at this point, well, let's do a couple of tests first, just because I'm curious. Go to ohms. I can actually do this with these leads. Go to continuity. We should see perfect. The box is grounded. The center pin here is earth, and it's connected. So from a safety standpoint, he's wired this well. The earth grounds the entire metal cabinet. Just look for straight. That's diode. We should see no connection at all. Back through. And we don't. So he's taken the earth ground, as he should have, on the input here, and he's grounded the entire metal box. And that way, if one of these wires rubbed through or solder joint failed, and the line voltage, someplace in here where it picked up line was to touch the metal box, that would get shorted back to earth ground and should kick out your circuit breaker in your power, but it keeps the box from becoming hot accidentally and creating a shock hazard. This isn't an isolated transformer, so it's not isolation. It's just variable. I also have an isolation transformer you could potentially use with this to create an isolated variable power supply. So let me go to volts. We'll get this switched over to AC. Right there. High and low, I don't really care. It's AC voltage. I'm guessing that is the equivalent of off from the AC line cord. We've got an AC line cord here. Go ahead and plug it in. We should see nothing here. And we essentially don't. There should be nothing as I set it mid-range here. Hopefully that's about 60 volts AC. Being middle of the road, 67 volts AC. So, pretty cool. Should go down to almost to 0, so quarter volt AC, and should come up with a full line voltage. As it does, apparently I'm at 121 volts here in the US at the moment. This is a little bit intriguing here. I could take like a 12 volt AC, a transformer with 12 volts AC, and I could feed it in here and then vary the output of that transformer, which is kind of cool. Well, it is what it is. It's a, I had read it as a variable frequency, and it's not. It's a, he's got it labeled 60 hertz. I guess technically that's what the auto transformer or the variable transformer is rated. Nice build. I like the circuit breaker. Look at the 2 amp circuit breaker, but it again would help keep the box safe, so he was thinking about safety when he built this. The grounds are correct. Don't know the gentleman's name. I don't think I ever learned it, but nice job. This is actually something worth having in my lab. I'm looking at the construction. It's okay. I mean, looking at it, I don't see anything I would change for safety. It very much is what it is. Trying to figure out how it's wired here. AC comes in. That's interesting. I'm assuming... That's kind of interesting. I'm a little confused with what I'm seeing there around the switch. So let's grab a piece of paper here and see if we can figure this out. That's kind of odd. There are 6 contacts on the switch. I would expect each side of this to be a double pole, single throw, so center can connect here or here, but that may not be true. We're center here and here. That may not be true. Are they labeled? If they are, I'm not seeing it. Let's get the test leads plugged in here. Well, that's what I get for sitting them down. Twisted in 2 knots. We're going to go ahead just to straight continuity. I don't expect these to be connected together, or these, or these. The switch is in the upright position, so I'd expect these two to be connected, and these two open and open. The switch is now in the down position, and I would expect now this to be open, this to be open. Continuity, continuity. Again, there should be no side-to-side connections. So that is what I essentially expected, is the contacts can slide up or down. So let's see, we've got, I'm going to draw this really poorly. I've got line and actually I drew those backwards based on what I'm seeing in there, I do believe. Anyhow, line cord comes to this position. The input jack, then we've got a set of jacks. So we've got the green, the white, and the black jack. And this black jack comes around over here on the switch. White comes to here. We've got the output jacks over here. Black, white, and earth, and I'm actually going to draw on the circuit for the earth. So the white is also connected to here, and we've got the transformer. With the tap here, as we'd expect out. White, I believe, to one side of the transformer. And the other side of the transformer comes to the fuse, and from the fuse it connects to here, and here as we'd expect. So this is the line and this is the neutral. The black is the line and the white is the neutral, which I believe is standard code in the US. So the neutral is just common all the way through, as it should be. The grounds are of course tied to ground. I just didn't draw the schematic in. The switch can be in this lower position, which means the input is being fed from the jacks on the side. Is that true? No. The input's being fed from the line cord. So we have continuity through here to the transformer, the output of the transformer back to the out. If the switch is in the other position, where these are connected here and these aren't, it then comes from that input jack, connected, and around again to the transformer. So it makes sense. It's wired like I would think it is. Sorry for the poor state of my little hand-drawn schematic there. And ultimately, I keep saying I'm not going to draw it, but we've got earth here in the center. And these are connected to the chassis. Is that the right symbol for chassis, or is it? Boy, it's been a long time. Anyhow, it's connected to the chassis, whatever the symbol is. So, I appreciate it. This is a nice little addition. This is something I will have use for occasionally. So I think with that we can wrap this one up. Do I have anything else to say about it? Certainly handmade. Make sure the screw holes kind of line up. And they don't. So maybe this way. That's better. That is the orientation that goes back on. Again, handmade aluminum plate here on the bottom. He drilled his own little screw holes here. No surprise. I think that upper case is a Bud case, I believe was the manufacturer. I could be wrong. It's got that look to it to me. Although who knows what it is. It could be anything from back in the era. I don't know what the gentleman did at Boeing. I've met a couple ex-Boeing engineers who were really interesting, smart people that I would have really liked to have gotten to know better, and who passed shortly after I met them, which was really, sad. I don't even know what word to use here. I would have really liked to have known both the gentlemen better than I did. Both characters, there's no doubt about it. I'm sure the owner of this stuff would have been interesting to have a conversation with for an afternoon as well. But I guess with that, I will get this thing put up on my shelf, because it's definitely worth holding on for me. I'll decide what to do with the resistor box we looked at in the previous video. And I guess we'll wrap this one up here. So I'll see you in a future video.